Have you ever wondered what actually happens to your password after you log into a website? Do websites store your real password? Not exactly. Most websites use something called hashing to protect passwords and sensitive data. Today, we'll understand hashing in the simplest way possible. What is hashing? Hashing is a process that converts data into a unique fixed-length value called a hash. A hash looks like random text and numbers. For example, input, password 123, hash output, 5F4DCC3B5A765D61D8327DEB882CF99. Even a small change in the input creates a completely different hash. Why hashing is important? Imagine if websites stored passwords normally, if hackers hacked the database. They could see everyone's real passwords. That would be extremely dangerous. Instead, websites store hashed versions of passwords. This improves security. How hashing works: when you create a password, 1. You enter the password. 2. The website runs it through a hash function. 3. The hash is stored instead of the real password. Later, when you log in, your password is hashed again. The new hash is compared with the stored hash. If both hashes match, login successful. Hash functions. Hash function is a mathematical algorithm that creates hashes. Popular hash algorithms include MD5, SHA-1, SHA-256. Modern systems prefer stronger algorithms like SHA-256. One-way process. One important thing about hashing is designed to be one-way. This means easy to create a hash, very difficult to reverse it back into the original password. That is why hashing is useful for security. Why two passwords create different hashes. Even tiny changes create completely different hashes. Example, password, hello123, hash, 1b2c3, password, hello124, hash, x9f7d2. This helps improve security. What is salting? Hackers sometimes use pre-computed databases called rainbow tables to crack hashes. To stop this, websites use something called salt. A salt is random data added before hashing. This makes hashes much harder to crack. Salting is a very important cybersecurity technique. Difference between hashing and encryption. Many people confuse hashing and encryption, but they are different. Hashing, one-way process, mainly used for verification, cannot easily be reversed. Encryption, two-way process, data can be decrypted using a key. Hashing protects passwords, while encryption protects readable data. Real-world uses of hashing. Hashing is used in many technologies, for example, password storage, blockchain, file verification, digital signatures, cybersecurity systems. Many modern systems rely on hashing every day. File verification. Hashing can also verify files. If even one small part of a file changes, the hash changes too. This helps detect corrupted files, modified software, malware tampering. Hashing and blockchain. Blockchain systems like cryptocurrencies also use hashing. Hashes help connect blocks securely and protect blockchain data. Without hashing, blockchain security would be much weaker. Can hashes be cracked? Some weak hash algorithms can be attacked. Hackers may use brute force attacks, dictionary attacks, rainbow tables. That is why strong hash algorithms and salting are important. The future of password security. Modern systems are improving security using strong hashing algorithms. Passkeys, biometrics, multi-factor authentication. Cybersecurity continues evolving every year. Now you understand how hashing works and why it is important for online security. If you want more simple tech videos like this, subscribe to Byte and tell me in the comments, did you know websites usually don't store your real password?